Hello everyone, this is Hating Tian. In this video, we are learning 5.3, sum and difference identities for cosine. Here are the two sum and difference identity for cosine. First one is cosine A plus B. In A and B, they are in the parentheses, equals cosine A times cosine B minus sine A times sine B. If I have cosine A minus B, that equals cosine A times cosine B plus sine A times sine B. So these two parts, they are exactly the same. Which part is different? So here is plus, I'm having minus. Here is minus, I'm having a plus. So spend some time, put the notes on the scratch paper or on your notebook. So practice several times until you can memorize the identity. So the angle A and B, they could be in degree or radian mode. We know the exact trigonometric function value of several angles on the unit circle. For example, I know that sine 30 degrees and the cosine pi over 4 and tangent pi over 6 and a lot of exact trig functions value. But sometimes we are not lucky to have these special angles value. For example, 0, 90 degrees, or pi. So these are all the special values. So if I make an angle that is not special for me, I can use sum and difference identities to convert it to what we have learned. So this part, we're not allowed to use our calculator. We can only use our hand. Okay, let's see the first example. Find the exact value of each expression. I don't have a calculator, but I need to find what is cosine 75 degrees. We only learned cosine 30 degrees. We only know that cosine 45 degrees. But how to find cosine 75? Can I say this one equals cosine 30 degrees plus cosine 45 degrees? No, they do not have the same value, because I know cosine 30 degree, that's square root of 3 over 2. And cosine 45 is square root of 2 over 2. And the sum of these two is the square root of 3 plus square root of 2. So this value is greater than or equal to 2, equal to 0, equal to 1. So the cosine will be never greater than or equal to 1. That means they are not equal. If you don't understand why I'm saying this, so remember, they are not equal. I'm using the identities of the cosine, the sum of the identities. The cosine 75 equals cosine 30 degrees plus 45 degrees. And then use the property, I can convert it to the cosine 30 degrees multiplied by cosine 45 degrees. So I need to minus or add or plus, minus, because this is plus. Then in the formula, I have minus sine 30 degrees times sine 45 degrees. I know the value of cosine sine for the special angles. Now I can evaluate the value. Sine 30 degrees, that's square root of 3 over 2. Cosine 45, square root of 2 over 2. Minus 1/2 times square root of 2 over 2. We got square root of 6 over 6 minus square root of 2 over 2. Oh, sorry, over 4. Bottom multiplied by the bottom. We have square root of 6 minus square root of 2. So we are done. How about next one? This is negative 105 degrees. So remember that if we have a negative angle, let's use even or odd of the function. Get rid of the negative sign. Cosine is positive or negative. Cosine is even or odd function. cosine is even function. If I have a negative here, that means I can take it away. That's cosine 105 degrees. And can you break the 105 into the sum of two numbers? Let me think. So I know that 60 degrees plus 45 can make a 105. Yes, I found it. And then use the formula. We have the cosine 60 degrees times cosine 45 degrees. Then minus sine 60 degrees times sine 45 degrees. Then puts the value inside is 1/2 times square root 2 over 2 minus square root of 3 over 2 times square root of 2 over 2. Okay, we have square root of 2 over 4 minus square root of 6 over 4. Combine them. We have square root of 2 minus square root of 6. All right, let's see next one. This is a radian mode. What is cosine negative pi over 12? So we have learned, get rid of the negative sign first. So this one equals cosine pi over 12. So what is pi over 12? We know that if I have 4 pi over 12 minus 3 pi over 12, this is pi over 12, yes? And we also know that these two, they are two special angles. They are pi over 3 and pi over 4. We know the pi over 3 and pi over 4. That means the pi over 12 can be written as pi over 3 minus pi over 4. Okay, this is cosine pi over 3 minus pi over 4. So why I can know that this is pi over 3 minus pi over 4? Because I solved so many questions. When I see the pi over 12, I immediately think of two special angles. They are pi over 3 and pi over 4. Okay, let's break it down. That's cosine pi over 3 times cosine pi over 4. Okay, I break the order. I break the rule, right? Break the order. Pi over 4. And then here is minus, I must have plus. Sine pi over 3 times sine pi over 4. What do we have? So cosine pi over 3 is 1/2. Cosine pi over 4, square root 2 over 2 plus sine pi over 3, square root of 3 over 2. And this sine pi over 4, square root of 2 over 2. We have square root of 2 over 4 plus square root of 6 over 4. Okay. On the top, we have square root of 2 plus square root of 6 over 4. Okay, we're done. How about number D? Cosine 173 degrees times cosine 128 degrees plus sine 173 degrees times sine 128 degrees. These two angles, they are not the special angles. How to find value of this? So let me give you the hint. Do you think we have met this one before? If I replace the 173 and 128 with the variable angle like alpha or beta, so can I say, how about cosine A times cosine B plus sine A times sine B? What is that? Oh, this is cosine A minus B. Okay, so I can simplify my expression. That is cosine 173 degrees minus 128 degrees. 8. So this is cosine 45 degrees. What is cosine 45? Square root 2 over 2. So we're done. This is a solution.